Hey, hi everyone, I'm TigerHawk3. Um, Today is a science and technology category day, which means Python. There were some modules higher up on the list than what I'm doing now, but they were large and complex and I haven't really used them before. Curses, which is an advanced text module for terminal stuff. Multiprocessing, which is using your computer's entire CPU instead of just one core, that sort of thing. So what I'm going to do is urllib.request. urllib is a package, not a module. It contains several modules in it. One of them is urllib.request, and there is urllib.parse, and also urllib.error, and urllib.robotparser for parsing robots.txt files. We're going to look at request. It's kind of big-ish, but there's some, looks like a lot of it is explanation. Let's see what we can do. Let's see what we can do today. Okay. Let's import urllib.request as R. How about? Great. The first function that it shows is urllib.request.urlopen, which opens the site at the URL you give it, and then gives you the content of the page. Let's try that with a simple page from my website that I know is extremely basic. So it won't, if we look at it in here, it won't be a pile of tags all over the place. Like if you go to google.com and right click on the page and then view source, it's there's a lot of stuff on that page that you can't see. So content equals r.urlopen /contact.html. Okay. There's data. Oh, you can optionally specify a bytes object to send to the server, which I'm not going to do. Should be a buffer, blah blah blah. Timeout specifies a timeout in seconds for blocking operations like the connection attempt. If you don't pick one, it uses the global default. Context, not going to use that. CA file and CA path specify a set of trusted CA certificates for HTTPS requests. Let's we're not going to do that. Okay. Enter. Great. What is content? It's an HTTP response. So I will have to do something with that. Install opener. Install an opener director instance as a default. No. Build opener. No. No. Path name to URL. Let's look at this one. So we have this content and we're going to look at it later. I assume there's a listing of a class, http.client.http response somewhere. r.pathname to URL. Local syntax. What would that look like? Pathname to URL. There's also URL to pathname. Percent encoded URL. It's not accept a complete one. Okay, let's use hi there. This is text. What does that give us? No, that's not a path. It's not a thing. Okay. No. What is a path supposed to look like? How about just how about that? Is that a path? It is. So this gives us let's actually print this. Okay. So we have slash slash slash, start with 3, C colon, and then it's a forward slash. Let's do my file.txt. Note over here, it's %20. You may be familiar with %20 because whenever you have you want to have a space in our URL, you can't actually do that. I think some browsers today kind of help you out, and you can use them, but it'll either still show them as spaces or automatically change them. But really, it's %20 because there can't be a space in our URL. Let's do r.url to path name with what we just did. Excellent. So that just reads the little encoding stuff and goes back to what you had. Classes, here we are. urllib.request.request. This was an HTTP response, okay. URL. So that's a class, urllib.request. urllib.request.request. And what does it do? What is it? Doesn't list any methods for this class. That's great. Okay. That's not super useful. It's an abstraction of a URL request. That's great. Let's skip it. Opener director, base handler, HTTP default error handler. There's a lot of stuff. Handlers, password manager, great. Auth handler. I don't care, I don't care, I don't care. Wow. Request objects. Full URL. Type. Oh, this is a request public interface. This urllib.request.request. It's lots of stuff, apparently. And they waited till later they first listed all the classes it has, and now they are describing each one in detail. The original URL, the type, the host. What have we got in content? A lot of stuff. Do we have... It's not the same... Yeah, because this is a HTTP response, not a request object. I don't care, I don't care. I really don't. Opener director objects. Yeah, no. The reason I'm skipping these is because you can make a nice little Python program with just URL open, and then you have the page. So, yeah. There's also What I'm using now is the sample page is just text, but you can also do it with any bytes object. Let's look at the length of this. Doesn't have a length. Okay. I probably have to read into read. Yeah, there's a read. It's off to the side here. So if you want a program that can open images from the internet, whatever you pass it, you can also do that with this. I have a sliding tile puzzle game that can open a picture with a specified path, or random pictures from a specified folder, or a picture from a specified URL. And it downloads and displays it. Very nice. Anyway, HTTP redirect handler, blah, 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 blah. Why is there so much stuff I'm not interested in? Examples. So let's just read. So there's examples at the bottom, but it doesn't tell me about this, I guess it would be in the HTML module. Anyway, HTML, no, text, how about, equals content.read. And what does that give us? A bytes object, not a string, because we just downloaded bytes from the internet. It doesn't know that it's text. Let's try to decode that. So, we have, notice how we printed it instead of just entering text and getting the reproduction of it. And even when we print, it still has this \n because it is bytes. We can decode it. Text.decode in UTF-8. Is it? No, it's probably ASCII. I don't know. How about now, huh? Aha! That's a little better. Okay. So the bytes object was just all this stuff, and it has a backslash and an N, and it doesn't really know what to do with any of that. But when I decode it and then print it, all of those new line, the line feed character, will, or the backslash and the N, will be interpreted as a line feed, and then we get something more like this. And now we can, since this is a very simple page, like I told you, we can just read it, because it's HTML, and it's very simple HTML. We have the start HTML tag, that's how it knows it's an HTML page, the head, and then we have a title, and then how to contact me, because this is my contact page on my website. And then we end the head, and then we start the body. Now we have a table. It's aligned in the center, width of 300 pixels, and then we have a row that we start with a height of 150 pixels. Then there's an empty cell, and we finish that row. And we start another row, and a new cell in that row. And then here's some, some text. And end the cell, end the row, end the table, end the body, and end the HTML page. That's it. It's a white screen with a little block of text in the middle. That's literally all it is. code, etc. Is it gonna talk about images? CGI, put request, we're not gonna do any of that. HTTP authentication. No. We are not doing that. Legacy interface, URL opener. I'll tell you what. I'm going to open this little sliding tile puzzle that I have. I'm sure it's somewhere. Memory tile, no. Wow, lots of stuff in here. Where's my sliding tile game? It's not open in Notepad yet, but I can fix that. Okay. Here we go. urllib. So where do I open it? Here we are. I will need to import something else, and I will do that. Okay. Ever so slightly non-trivial. I don't even know where to put the window. How about right here? I don't know. Okay. Here's what we're going to do. Here's what we're going to do. I'm going to import tkinter and pil and io. Import tkinter as tk, import pil. Let's do from pil, import image and image tk. And also IO. So this is how we're going to read images. So what are we going to do now? First, I will find an image on the internet to read. How about something from Wikipedia? In English. Thank you. How about today's featured picture? An assignat banknote issued in 1792 with face value of 400 livres. An early French banknote first issued in 1789 during the French Revolution. Okay, backed by the value of seized properties. How delightful. Amidst widespread counterfeiting, limited use, and opposition from counter-revolutionaries, it devalued quickly and was replaced by the mandat in 1796. Alright. Let's get this image. Is it this? Wow, that's a... Okay. Alright. So, picture URL is going to be... I'm starting a triple quoted string because I don't know if there's a quote in there. I don't think there's supposed to be. Very long. Okay. And I'm going to turn this into a bytes IO object. This is going far out of the realm of simple doing a thing sort of stuff. But I'm doing it anyway, because that's like the only other interesting thing I can think of with the urllib. And it is interesting. It's not like, well, there's nothing here, so I guess no, this is something that we might want to do. So we're going to do it, even though it uses some other libraries. I'm using the pillow fork of PIL. PIL, the Python imaging library, has not been updated in several years, and some group forked it, meaning they copied it to their own repository and are making improvements to that. And it's kept up to date and stuff. Pick bytes is going to be io.bytes.io. Actually, let's do something else first. The pick request is going to be... Actually, you know what? Let's do this to make it tidier. URL equals pick URL and picture what request is going to be urllib.request.url open picture URL dot read. Okay. And this, alright. So it took a second to get that image and read. If you noticed, it wasn't instantaneous like most things are, most small things. And the image is going to be image.open the request. What the? Why did it do this? Why did it do that? Oh, it traced back. Oh, great. File not found. So the file that wasn't found I had to do io.bytes.io first. Okay. So we have the request that we read, and the bytes is going to be an io.bytes out of this. Sorry about that, everyone. I missed a step. And then, my goodness gracious me. Why is it the whole thing? Why is it getting doc type HTML? Why does it have a page? That's very odd. Let's get this instead. And let's call this URL, the request. Okay. URL is going to be that. Picture request is going to be your r.url open with the pictures URL dot read. It's great. And the picture's bytes will be io.bytes io. This is what I had skipped. .bytes io with the picture's request. Okay. Picture image equals image.open. The picture's bytes. Okay. All right. Isn't there an image TK somewhere that I use? Image, with a tile, etc. Where's the next one? Do I ever do anything with that again? I think I can do it. I hope. Image equals this. Photo image for this tile. I'm trying to make basically an MCVE, a minimal complete verifiable example out of a full program. Where do I actually create the image? I think here's what I'll do. I'll just start doing stuff. Root equals tk.tk, and I will show you this. I think I have that, don't I? Gotta move that source way up. There we go. Cool. Now you can see over here. That's fine. I think I'll have to resize it because I'm going to put a picture into it. How about what's next? MHTK, is that how I do it? Image data. Image. I think eventually I do something with all this stuff. Okay. Append, etc. Okay. Tile, whatever. ID, column, row, my goodness. This is complicated. It works though. It's a pretty cool program. If you don't know what a sliding tile puzzle is if you're not familiar with those, you have a grid, usually square, with a picture or something, and the picture kind of rests in a little frame, and the picture is split up into a grid with one piece missing. And then all the tiles can be slid around, you know, and move this over there, and then move this into the blank space, and then move that into the blank space, and they are shuffled, and then you have to slide them around to rearrange the picture into its original form, and you can just kind of use your imagination for the missing piece. This one, since it's electronic, you can actually, it fills in the missing piece when you finish. Pretty simple concept. How do I actually put it in there? Spares this, shuffle that. Tiles this. That equals, interesting. There's a lot of stuff here. This is a 500 line program, by the way. Works pretty darn well, though. I already mentioned that, didn't I? Inversions, etc. So where does it actually create each tile's image on the board? Okay, I have lots of comments on this one. You may have noticed in my scripts that I've been writing on stream, there aren't really many comments. I think the parser I went through and commented at the end, but if I want to figure out what I'm doing on something that I had on stream, I can just watch the stream. Not really as efficient, but that's okay. Okay. Let's make a canvas in here. Canvas equals tk.canvas in the root. Sounds good. I'm gonna actually place it in there, and now it's bigger. Canvas.create image. This is a method on a tk-enter canvas. There are many similar ones like create rectangle, create ellipse, oval. Not sure if it's oval or ellipse. Anyway, create rectangle, create image. I think there's a create text. Not sure. But anyway, create image, so it's gonna have an image, little, not a separate widget, but kind of an object there on the canvas. Canvas.create image. Let's put it at 0, 0. Anchor is tk dot, so I can just do this, I think. Capital, lowercase. Let's use the constant. tk.northwest image equals the picture. You can't see any of that, can you? I'll move things around again. Don't worry. Picture image. Okay. Is that it? This and that. This image equals whatever. Didn't like it. Image doesn't exist. I need the tiles image. Oh, it needs to be a tk.photo image. Okay. I want to play that game. The picture's tk image will be image tk.photo image. So this is PIL is providing an interface between its image processing capabilities and tk-enter. Natively, tk-enter can open GIF files, AIFF, some other weird things that I've never heard of, Not sure whether it can do BMP, I don't recall. Anyway, it's very, very limited. But what you can do is you can use PIL to image, use PIL, and it will convert the images of basically any format that you provide into something that tkinter can understand. Alright, let's try this again. Not the same one. I need the TK image, like, for real. Come on. Aha! So this is, I'm gonna cover the thing so you can see. It's a little cut off. That's okay. But yeah. Anyway, let's say I'm going to make, I can't resize the ordinarily you make a tkinter application with by writing a script and then having a main loop in it and then it runs, etc. But how would you do that in the interactive interpreter? You would do the main loop and then it would be right there, and then you wouldn't be able to do anything until you closed it. It's kind of limited. So there's a kind of little workaround that they did that allows you to kind of place things into a tkinter application interactively, which is very, very convenient. But if you have anything typed, if you've been typing something into the shell here, the tkinter window becomes unresponsive. So that's why I did this, and now I can increase the size of that. What I'm gonna do here is canvas equals tk dot canvas. In the root, actually, I think it's destroy first, right? Yeah. Canvas equals tk dot canvas. I probably didn't need to do that. I could have just reconfigured it. That's okay. Let's go ahead and do that. Put this in there. Why didn't it put it in there? I don't see it. That's odd. Let's start over. Shouldn't take too long. Canvas equals tk dot canvas in the root. Canvas dot create image this thing. Did I do it wrong? Oh, it was cleaned up or something? That's great. We will do it. I swear to you. Equals picture image equals image tk dot, what was it? What did I do to get that? Image tk dot photo image. With this, we'll make a new one, and then we'll say yes, please do it. I have to pack the canvas. I totally forgot about that. Now it's there. And let's see, we have, what we actually have here is The reason it's doing this is the canvas itself is only this big. The canvas isn't going to magically expand just because we change the size of the window. So we will do this for now. Canvas.config height equals 600. That's a little more. Did you see that? Still not big enough. Or is it? Yes, it is. Canvas.config width equals, how big is that image? Does it say somewhere in this URL? 1024. Maybe it's 1024? I don't know. Alright. Can we see the whole thing? We can! Splendid. Now I'm going to take this and do what I should have done initially, and I can make it smaller. Now we have a thing. So there you go. And this is from the internet. It is not saved in a file on my hard drive. Okay, maybe like a temporary folder somewhere. I don't know. Screw you, computer. But point being, this is a picture that I didn't have to save in a local file and then open as a local file. I just downloaded it programmatically. So if you had an image server somewhere and you wanted to have a slideshow of them in Python, not the most efficient idea. You can just probably be best to just make the page already do that. Just do it in the browser anyway. But if you wanted to do some fancier processing, like making a sliding tile puzzle game. So that's urllib.request with the key features urllib.request.url open. And I know there was something else. Request fancy URL opener deprecated. Wasn't there something else here? Legacy interface, examples. That was pretty much it in terms of things you will likely use if you want to open files on the internet. urllib.request.url open. And then you have to read it into a bytes object. If it's text, you might want to decode it with whatever encoding you think that site is using for that text. And it might be like ASCII or UTF-8. And if it's something else, you can read that as a bytes object. Could probably download arbitrary anything. Like if you have a PowerPoint in somewhere or a PDF. I'm sure there's a... yeah, I could probably do that. Here's what I'm going to do. We have our image is what? Type of picture image. What is that? It's a PIL image. How about the request? That is a bytes object. So here's what I'm going to do. With open C users, that's me, desktop, image dot, I think it's a JPEG. Write bytes. Can't see any of this. Let's take that out. We don't need that. It has outlived its usefulness of being on the screen. Write bytes as output. Output.write. Picture request. $241K. So now I have an image.jpg on my desktop and I open it, and indeed it opens in my standard photo viewing, the default photo viewing application, and that's what it is. I can show you. Don't I have the monitor in here? Yes. Up the source goes. I had the source in the list already, but I have to move it up. Here we go. See? So here we are. Let's get my face. Here we are. So there you have it. So you see it's just a file on the that I can open. Because I just wrote the bytes to a file and it works perfectly fine. So I'm gonna close this, delete this image that I no longer need. Oops, this is too high up. There we go. So that is that's cool stuff, I think. Lets you work with stuff that you got online. Anyway, I think, how long has this been going? 46 minutes? That's pretty long for only showing a single function in a module. But you saw some cool things you can do. Note that if all I wanted to do was save the image, then I didn't have to import IO or anything from tkinter or PIL. All that was just to be able to display the image in tkinter. And yeah. So if you just want to grab files from the internet, you can URL open and then read it, and then you have the bytes object. And you can write that bytes object to a file as long as you do specify write bytes as the mode, so it doesn't try to interpret it as text or something. And that's it. It's pretty simple. Yeah, the only reason I had to kind of do some more messy stuff with it was because tkinter does not happily work with other formats, and you have to juggle that stuff around. So, that's the stream for today. Tomorrow I might play LOL, or I might do some trucking in Europe. I've also been playing that offline because sometimes I feel like it. There's always some joker who thinks that they're going to ram an 18-wheeler. Like, the light will be green, and I'm like I'm going forward an intersection, and I want to make a left, although that's a right for you, but I want to make a left, you know? Left. Anyway, I want to make a left, right, over here, to go this way, and someone else wants to come from here and make a right. No. They want to go the same direction I do. I want to make a left, and someone coming from the opposite direction wants to make a right. I will figure out this camera direction stuff. Going to the left. That going this way looks like it would be, no, it would have to be like this. So I'm going from the right. We have the left side of the road and the right side of the road, and I'm going to make a left. Okay. And as I want to do this, someone from here wants to do that. This is complicated. So I want to make a right. Right. I want to make a left. And someone from the opposite direction wants to make a right. Anyway, so as you can see, this over here, I want to go over here, and they want to go over here as well. This light will be green, and then I go, everything's working out, there was nothing in the other direction, and then suddenly a car spawns or pops into view or something, and decides to ram me. Clunk. And it's like, that's great. I'm hauling, you know, cyanide or something. You want some of that? Like, 'cause if you break my truck, it's gonna... cyanide or hot chemicals or something. You don't want that. I got all sorts of certifications, man. The little signs on the truck. Like, stay away from that. There's always some joker who wants to do that. But sometimes, I'm waiting at a stop sign for cross traffic that doesn't stop, and someone decides to stop for me so that I can actually go. And I'm like, thank you. I go like this. Thank you. You're awesome. Like, for real, for actual. I have not seen a button in the control section to wave to someone. So anyway, tomorrow probably LOL or Euro Truck Simulator 2. Day after that, I don't really have any idea. I need this, I can close this. I can close that. Okay. What will tomorrow bring? Welcome to the world of tomorrow. HTTP? FTP lib? Pop lib? IMAP lib? SMTP? NNTP? Probably none of these. UUID? Isn't that a small one? Maybe we'll do that. Sort of. Yeah, this is doable. Maybe day after tomorrow we'll do the UUID. And the whole point of that is to generate a unique identifier. What does UUID stand for? It doesn't say. UUID? Nope. It's not going to tell me what it stands for. Okay. It's to make unique IDs. And they can be very long and random. But, so that's probably going to be 2 days from now, and tomorrow I'm going to do some trucking. Trucking is, pretty decent. Sometimes I get annoyed that they simulate the unfun parts as well. Like crazy drivers wanting to run into you and waiting at a stop sign for half an hour. I think the time actually simulates and slows down when you when you're stopped. I don't really know how that works. But anyway, I think that's enough rambling. No one's watching. It's okay. I will see you next time, and have a good one.